All right, so now we are on section 2.6. So this is going to be a little more graphing linear equations. We did a little bit of it last time, giving you 2 points, graphing a line. Mostly we're talking about slope. So we're going to move into graphing a linear equation using intercepts. So we already know about y-intercepts. So now we're going to talk about y and x-intercepts. Oops, let me get this down here. So to the left, we have a graph of 1/2 x minus 4. And just a quick reminder again. You can think of this as just being a y, so y equals 1/2 x minus 4. So reminder, slope, that is your y-intercept. But if we graph the function, we see that we get your y-intercept. It's over here. It's a little hard to see, but that point is 0, -4. But we also have another intercept up here. And this is what we're going to call your x-intercept. And that one is at 8, 0. Which I thought someone was at my door. So let me put that down there. That's your y-intercept. As you see, it is intercepting the y-axis. This here is your x-intercept, because it intercepts what we know is to be your x-axis. All right, so we're going to look at this a little bit more. So we would say that our x-intercept is here at, like we said, 8, 0. But we could also just say it's x equals 8. And the y-intercept is at 0, -4. So we can get that in there. Or, like as we said before, we can just refer to as y equals -4. So one of the things to take notice here is that this is my y-axis. So my y-axis is this whole line here where your x value is 0. So sometimes we just call your x-axis, your y-axis, sorry, x equals 0. It's the equation for that line. But also know when you talk about your y-intercept, that's when x is equal to 0. When you talk about your x-intercept, if you look at that whole line there, you'll realize that this whole line happens when y is 0. So the equation for your x-axis is actually y equals 0. And once again, when you talk about your x-intercept, that is when we're seeing that y is equal to 0. So this page is just me reiterating that same idea here. But this is an important idea, so we want to keep going on about it. So x-intercept occurs when y is equal to 0, which is what we were saying on the previous page. And your y-intercept occurs when x is equal to 0. So a lot of times, especially in algebra, there's a lot of things you got to think about as opposites. You want an x-intercept, y is 0. You want a y-intercept, x is 0. But we're going to put this to good use. So let me write our equation on here one more time. Write something a little darker. So we had y was 1/2 x minus 4. So that's the equation for your line that we had originally. So one of the ways that we can find x and y-intercepts without actually having to do any graphing or anything is we know where those points occur. We know y-intercept occurs when x is 0. So all I have to do is just replace all my x's with 0. Ignore that for now. Just think about that as being y. Y equals 1/2 0 minus 4, meaning that y is just going to be equal to -4. So we got an ordered pair of 0 minus 4. That's my y-intercept. And for this side is going to be my x-intercept. So as we said before, x-intercepts occur when y is equal to 0. That means I can take that same equation I had before, and now it's this y I'm going to replace with a 0. So I would have, instead of y equals 1/2 x minus 4, 0 equals 1/2 x minus 4. So what I can do here is I just added 4 to both sides. So it goes over here. So then we have 4 is equal to 1/2 x, multiply both sides by 2, x is going to be equal to 8. Right. So just to make this a little clear here, a y-intercept is going to be point 0, b. So if we want to figure out what b is, that means that x would have to be 0 and we'd solve for y. An x-intercept we'll call a point a0. And to find that a, we would have to then let the y equal 0 and then solve for x. So as we did already. I'm not sure what happened there, but we want to find the intercepts of 5x plus 2y equals 10, and then we're going to graph. So this is still a linear equation. As I mentioned previously, that if I wanted to, if I solved that for y, I would have your slope-intercept form or your y equals mx plus b. But we don't need that here. This is what we like about intercepts. It's really easy to help us graph in certain situations, especially with an equation like this. I have less work to do. So remember, if I want my x-intercept, a second to think about this, I would need x or y equal to 0. All right, that's a Door Explorer moment there. Stare intensely at the screen, and hopefully you had answered y equals 0. If we want my y-intercept, I think we already know probably now, that would have to be when x is equal to 0. So we'll take our equation here. 5x plus 2, well, not y now, but 0 equals 10. So we're going to be left with 5x equals 10. And x is just going to be equal to 2 then. So we have an ordered pair where x is 2 and y is 0. All right. Same thing over here, except now we're going to have x is 0. So 5 times 0 plus 2y equals 10. Once again, 5 times 0, that's going to be 0. Leaves me with 2y equals 10, and y will equal 5. So that gives me another ordered pair of 0, 5. So it's a way to easily get points here because I can put in my x and my y intercepts. They're easy to find and graph. So we have 0. Sorry, we have 0, 5. I was pointing at the wrong one. 2, 3, 4, 5. And then we have 2, 0, 1, 2. Like I said, another way to think about that is, oops, right here. X is equal to 2 here, y is equal to 5 here. All right, just because we're learning, I'm going to label those points. And then the rest of this is easy peasy. You just need to put a line through it. You can watch me fail doing it a couple times here. There we go. And there we go. We've graphed that line. Now we know that's what that line would look like. So with some other benefits of this is we can easily identify things like slope and stuff like that without having to solve the equation for y. Probably better to solve the equation for y, but like I said, this helps us avoid having to deal with writing everything as y equals mx plus b. We can still find 2 points very quickly. So graphing with x and y intercepts. So just some notes here. Since we only need 2 points to graph a linear function, we can use the x and y intercepts as those 2 points. However, we can't always do this. Note that not all graphs of linear functions or linear equations, let's write that in there. We're talking about the same thing here for talking about a function or equation right now. Not all graphs of linear equations will have an x and y intercept or distinct intercepts. So the distinct intercepts, if you remember, we had those graphs before where we passed right through the origin. And we said that origin at 0, 0, well, that's where x is 0 and that's where y is 0. That means that both the x and y intercept are exactly the same. So like I said, sometimes we don't have an x and a y intercept, and sometimes we don't have two distinct x and y intercepts. So pretty much all of these, there are places where it kind of falls apart as a good method for graphing. That's why we have several methods. But if you take a moment here, so, oops, I think I passed the first one. Nope, I didn't. You should have a couple of these. So 1, 2, sorry, you should have 9, 10, 11. Oops, do that right. 12. I'm sorry, 12 of them. So work through 9 through 12 on your worksheet. Some of these last two here, as you notice, I give you this down here. These are going to be some of your unique cases. That's why this is provided to help you kind of graph the line, because you're going to not be able to find two intercepts. Okay, so hopefully you took some time to do that. If you struggled on, that's okay. We're going to go through this. So once again, if we want our x-intercept, we're going to set y equals to 0. So we have y equals 1/3 x plus 1. Well, now it's going to be 0 equals 1/3 x plus 1. So we want to isolate that x, solve for it. Subtract 1 from both sides. We have 1/3 x. We want to deal with that 1/3. So if we multiply by 3, I'll get rid of that 1/3. So we'll have -3 equals x. And like I said, if you don't like that, just change it around to x equals -3. That's going to give me a point of -3, 0. And that is my x-intercept. For the other one, we are going to have x is equal to 0. So we'll have y equals 1/3 times 0 plus 1. And this is going to be the really hard one here. This is going to take a long time. So 1/3 times 0 is 0. So we're left with y equals 1. Okay, I was messing with you. That's an easy one. So in this case, we get 0, 1 is that intercept. Like I said, we probably didn't need to go through that extra work there because we already did all the extra work of knowing that if I'm in the y equals mx plus b form, this is my b here. That is my y-intercept. So let's finish this off. Okay. Didn't get that quite right. There we go. Didn't quite fit in there perfectly, but we'll call it good enough for right now. But that would be the graph of y equals 1/3 x plus 1. All right, so number 10, that was y equals -3/4 x plus 1. So we're going to do one part really quickly here. So as a reminder, like we did last time, we noticed that this is in our slope intercept form, y equals mx plus b. So we know that this is y-intercept. So like I said, we don't have to do all that extra work of solving for 0 for this case because we already know, or sorry, x is 0, solving for y. We already know this one. We know y-intercept is going to end up being x is 0, y is 4. That x-intercept is really where our work's going to be. Once again, this is going to occur where y is equal to 0. So I'm going to have 0 is equal to -3/4 x plus 4. Subtract 4 from both sides, and we're going to see what kind of fun we get out of this. So we're going to get -4 over here. Sorry, -4 over here, -3/4 x. So we can do this in little baby steps here if you need to. We got this 4 here. So you could just multiply both sides by 4, because that will eliminate that 4. Since we're dividing by 4, we'll multiply by it. If you didn't do it quite this way, that's fine. Negative 16 should equal negative 3x. Well, now we have to divide by a negative 3, which means we're going to have x over here, and we're going to have 16/3. Or x is 16/3. So that means that x-intercept is some point that is 16/3 in 0. All right. So 16/3 would be, you could do this in a calculator probably. If you did this, you probably would end up with, depending what your calculator is, but you should end up with a 5.3 repeating. Well, that's just 5 1/3. So that's a 5 1/3 and 0. This is one of the places where finding intercepts may not be the best option. It may have been better to just pick another point for x and solve. As you see here, like we got 5 1/3. Well, first off, we had the problem that my graph doesn't go that far. Say 6 was out here. Well, I'm looking at my point being right about here. I can't tell you exactly. It's about there. That's all I can tell you. All right, best, I'm gonna get in there. So like I said, this is one of the places that finding x and y intercepts may not be the best option for us, simply because we're not getting nice clean integers. We're getting these fractions and decimal answers. And once that starts happening, it becomes a little harder to graph. But if you're going to do this in the real world, you'll end up with decimals and fractions anyway. All right, so questions on your worksheet 11 and 12. I'm going to do those on the next video. So like I said, just start the next one and you'll see those two finished.